In this video, I'm going to briefly introduce you to how we represent fractions in binary. Okay, so we're going to talk first about how we can represent fractions in binary using a fixed point system. Okay, so we're going to be dealing with bytes today, and so what we need to remember, okay, just to revise, is that 1 byte equals 8 bits. Okay, so now if we're using a fixed point system, what I'm going to do is I'm going to write out a binary number here. There we go. Okay, and I'm going to say that my fixed point is going to be right in the middle. Okay, so there's my point. All right, so the way this works is the ones, obviously the digits to the left-hand side of the decimal place, they are exactly the same as you would expect normally. Okay, so these are all our powers of 2, so 1, 2, 4, and 8. All right, so on the left-hand side of the decimal place, we have got the number 11. Okay, now let's think about what the right-hand side of the decimal place is. Okay, now interestingly enough, and hopefully you've spotted this, okay, our powers of 2 are going to continue. All right, so let's just review these. This is 2 to the power of 0. Anything to the power of 0 is 1. All right, this is 2 to the power of 1. This is 2 to the power of 2, and this is 2 to the power of 3, okay? Now, if we're going to go the other side of the point, what's going to happen, okay? Well, actually, all that happens is these still represent powers of 2, but they're going to go negative. So this represents 2 to the power of minus 1. All right, this is 2 to the power of minus 2. This is 2 to the power of minus 3. And this is 2 to the power of minus 4. Okay, now I don't know if you know these or not, but 2 to the power of minus 1 becomes a half. Okay, 2 to the power of minus 2 is a quarter. This is an eighth, and this is a 16th. And obviously these are just those positive powers of 2 underneath a 1. Okay, so we've got half, a quarter, an eighth, a 16th. Okay, so now all we do is we just do what we did on the other side, add them all together to work out what we've got. So here we've got a half plus a quarter, all right, which means we've got a half plus a quarter is obviously 3/4. So we've got 11 3/4, which is 11.75. Okay, so that's how we can represent fractions in binary using a fixed point system. Now, I just want to talk to you about the limitations of this. Okay, so obviously one of the limitations with this is there's a limit to how many numbers with this fixed point, with this fixed decimal place, that we can represent. Okay, so if we leave it where it is, okay, we can't represent a number bigger than 15 on the left-hand side. Okay, and we can only go so far in terms of detail on the right-hand side. Okay, and if we move the point, okay, so say we move the point to here, well, now we can represent more numbers on the left-hand side, but we can represent fewer numbers on the right-hand side. Okay, so that the fraction becomes less precise. Okay, so we need to decide: do we want to represent here? We've got to make a decision with a fixed point system. Do we want to represent bigger numbers with less accuracy in terms of the fraction, or do we want to represent smaller numbers but with more accuracy in terms of the fraction? All right, which is just something that we don't really want to have to worry about. So what we can do, all right, and I'm going to scroll down to get a bit more, is we're going to put this, let's write out this number again. Oh, sorry, I had that eraser on. Okay, so what we can do instead is we can use what's called a floating point system. Okay, so what we're going to talk about now is just this floating point idea. Okay, now with a floating point system, what we're going to do is all of a sudden what's going to happen is we're going to split this up again. So this part of our number is something called the mantissa. So on the left, this is the mantissa. All right, and on the right, sorry about that. Oh, it's very annoying, this iPad. On the right is the exponent. Okay, now the way this works is basically what we're going to do is the exponent is used to tell us where to place the decimal place. All right, and then the mantissa is going to stay the same, but the decimal place is going to move up and down inside that mantissa, and I'll show you what I mean by that. I'll just change the color. Okay, and so what we're going to do now, this is a normalized system, okay? So we're not going to go into detail, that's beyond the scope of this video, but basically what we mean by a normalized system is we've agreed on where the decimal place is going to start, okay? So the decimal place is going to start here. So there's our decimal place, okay? Now, what happens now is these two digits here represent how much we move that decimal place, okay? So in this situation, we've got 0, 0 here, so we're not going to move the decimal place at all, okay? So that means this number represents, well, this is a 1 over here, okay? And then we've got plus a quarter, obviously this is a half, don't forget, plus an eighth, plus a 16th, plus a 32, okay? We can do that, can't we? Let's do that. So what's that? We have to put them into 32s, don't we? So 4 is 8. That's 8 32s plus 4 32s. You can probably do this quicker than me. I'm a bit of a doofus. 2 32s. Okay, plus 1 32 equals 32. There we go. 8 and 4 is 12. 14, 15, 32s. Okay, that doesn't come down anymore. Okay, so we've got, so this number becomes 1.15 over 32. Okay, so there's that number. Okay, now let's have another go, but change it slightly. Okay, so this time what we're going to do, I'm going to write almost the same number. So we've got 1, 0, 1, 1, 1, 1. Okay, but this time we're going to put 1, 0, and again, this is going to be our exponent. This is our mantissa. Okay, again, I'm going to start in green. I'm going to put my decimal place in green. So our decimal place is going to start here, but this time our exponent is 2. Okay, so what we're going to do is we're going to move our decimal place 2 places. So we're going to go 1, 2, all right, which is there. So now we've got a different number, okay, because the exponent was different. So now we've got, and I'll write it out again with the decimal place in points, we've got 101.111. Okay, so again we do the same thing. This is 4, this is 2, this is 1. So we've got 5 point, all right, and then we've got a half, plus a quarter, plus an eighth. Okay, which is 7/8. We've got 5 and 7/8. All right, so that's how we can represent a decimal. That's how we can represent what's called a floating point number. All right, a number with a fraction. Okay, so we can either do it in a fixed point way, where the decimal place is fixed. Okay, or we can do it using what's called a floating point. And you will, as you develop your programming language skills, okay, you will find out. You will see lots of times that we say we call numbers like this, we call them floating point numbers, and the reason is because that decimal place floats, okay, because it's split into a mantissa and an exponent, and the exponent tells you how much it floats. All right, so thank you very much for watching this video on how to represent binary numbers as fractions. Thanks very much.